Hello students, we have 12th exercise problem, actually first one of additional exercise problem of chapter 7 in this video. The question is, an LC circuit contains 20 millihenry inductor and 50 microfarad capacitor with an initial charge of 10 microcoulomb. The resistance of the circuit is negligible. Let the instant the circuit is closed be t equal to 0. And with this situation, we have several questions given. What is the total energy stored initially? Is it conserved during oscillations? What is the natural frequency of the circuit? At what time is the energy stored completely electrical, that is in capacitor, completely magnetic, that is stored in inductor? At what times the total energy is shared equally between inductor and capacitor? If resistor is inserted in the circuit, how much energy is eventually dissipated as heat? So a bit lengthy question but not difficult. Let's start with data collection. We have L 20 millihenry, that is 20 into 10 raised to minus 3 Henry given. Capacitance C is 50 microfarad, that is 15 to 10 raised to minus 6 farad. Initial charge, let it be Q0, that is 10 millicoulomb. So 10 into 10 raised to minus 3 coulomb. And then we have several questions given. So if we look at first one, A, how much is the total energy? So total energy we can find out with the formula U is equal to Q square by Q0 square by 2C. We have Q0, we have C, so we should be able to calculate. Actually, this is the initial energy of capacitor and total energy of circuit both, and this energy is conserved during the LC oscillation provided there are no losses of energy. In LC oscillator, losses are mainly due to two reasons: resistance of the connecting wire and radiation loss. So if we neglect those two losses, the energy is conserved even during oscillation. Second question is, what is the natural frequency of circuit? So there also we just have to plug in the values in the formula. Omega is equal to 1 by root LC, and F, natural frequency F, is this. This answer should be around 160 hertz. So if you find out time period t, which is 1 by f, it will come out to be 6 millisecond approximately. Now, what does it mean? What is the significance of this time, 6 millisecond? We'll realize it very soon. See, in case of LC oscillator, the electrical energy, energy stored in the capacitor, can be given as UE is equal to half Q square by C. So at any given time, it will be Q0 square cos square omega t by C. And similarly, for inductor, the formula is half Li square, that is half Q0 square sine square omega t by C. You'll need to do a little bit of math to reach from this formula to this one, or else you can check previous video. In last illustration, this formula was derived, it was explained there. I'm not repeating that. You may go through it. Now, here the essential point is that if you look at this formula, it says that omega is 2 pi by t into t. So if I want total energy to be stored in the capacitor only, what I have to do is I have to have cos theta to be 1. Okay, and for which values cos will be 1, for which values of time the this answer will be 1. So we know that if you want cos 2 pi by t into t to be 1, it is possible if 2 pi by t into t is either it is 0 or pi or 2 pi or in general n pi. So comparing this 2 pi by t into t with n pi, we realize that t can be n t by 2. It means that for any time like 0, that is initial time, or t by 2, or t, or 3t by 2, or 4t by 2, that is 2t, at all this instance of time, the electrical energy will be maximum. Energy is stored in form of electrical energy in capacitor, and magnetic energy will be 0. Now similar exercise similar to this you can carry out for inductor also. When the energy will be stored in inductor, so instead of this cos, take sine. Okay, and then you will realize that for sine theta to be maximum, instead of considering the values to be 0, pi, 2 pi, n pi, you will have to consider values like, you will have to compare 2 pi by t into t with 90 degree, because sine 90 is maximum, 3 pi by 2, 5 pi by 2, and so on. So when energy is stored in inductor completely, so carry out this exercise for sine and you will get some value of t, and those are the values. It should be like t by 4, 3t by 4, and so on. So at all those instances, energy will be fully in form of magnetic energy in inductor, and capacitor will be having zero energy stored at those moments. Moving to the next one, D. At what times the total energy is shared equally in the inductor and the capacitor? So let us check that. We want we want energy of the capacitor to be half. We want energy of the inductor to be half. Okay, we want equal distribution. So we know that total energy is q square by q0 square by 2c, and energy in the capacitor is q0 square cos square omega t by 2c. So from this we realize that q0 square, if this condition is satisfied, sorry, I made mistake here, it should be q0 square by 2. Why? Because we want u by 2, so I'll have one more 2 here. So this 2c and 2c will get cancelled out, and left side will be q0 square by 2. So then we realize that if 1/2 is cos square omega t then the energy will be half of total. So I can say that cos omega t has to be 1 by root 2, and then omega t has to be pi by 4 or 3 pi by 4, okay, or odd multiple of pi by 4. So 2n minus 1 into pi by 4, that is 2 pi by t into t. Simplifying, you'll get that it is 2n minus 1 t by 8. For all these values of time, the energy in the capacitor will be half, and then you can derive similar thing with this expression also. If you take total and half of total energy to be energy in form of magnetic field, you will see that q square by 2, see this is total energy, and divided by 2, that is u by 2. Compare it with half Li square and simplify, you will get the same answer. So this is the time, or these are the instances of time when the energy is equally distributed between capacitor and inductor. Lastly, what will happen if you insert resistor? If you insert resistor, resistor is dissipating energy, and then the energy will be gradually converted into heat. So how much time it will take, that depends on the resistor value, but whatever energy you have stored in the circuit will be gradually dissipated in form of heat energy if resistor is added to the circuit. So that was the problem. I hope you could understand. Thank you.